Hey guys, welcome back. This is part two of your Punnett Squares notes. So I just wanted to kind of go back and review your vocabulary here. So a Punnett Square is a graphical representation of the possible outcomes of an offspring. Okay, so the purpose of doing one of these Punnett Squares is to say, okay, so I'm crossing parent one and parent two, and I want to find out if I do this cross, what percent of my offspring will be blue or what percent will be purple? So just to kind of refresh you on some of your vocab here, a genotype is the combination of alleles for a particular gene. Okay, so little b, big B, little b, those would be genotypes. Your phenotype is the physical appearance of the genotype. So your phenotype would be blue skin or purple skin, or whatever trait it is that you're following. Dominant alleles are alleles that show their effect even if only one is present. Okay, so in a heterozygous organism where you only have one big B and one little b, that organism will always show the dominant allele. The recessive allele is still there, it's just not going to be expressed. Recessive alleles are alleles that only show their effect if its paired allele is identical. So little b and little b are both alleles, okay? And when they're both the same, that's known as being homozygous recessive. And I know it's recessive because it's lowercase, okay? And then heterozygous means that the two alleles are different. So for example, big R, little r. Both of those alleles, big R is big, little r is little, they're both different, so they're heterozygous. Okay, so let's look at this cross here that we're doing. So here I have parent one is homozygous recessive. So remember that prefix homo always means the same. So I have two of the same allele, two recessive alleles. And over here, parent two, also homozygous recessive, okay? So just recall that each box represents a 25% likelihood because 1 out of 4 is 25%. So I'm just going to bring my little b over, little b down, little b, little b, little b, little b, little b, little b. So here you can kind of see all of my offspring are little b, little b. So question one says, what are the possible genotypes from this cross? Well, I only had little b, little b. What are the possible phenotypes from this cross? So every single one of these will express the recessive allele. And if I go back and look here, blue skin is big B and purple skin is little b. So all of them will be purple. What percent will be purple? 25 plus 25 plus 25 plus 25. 100% will be purple. What percent will be blue? Well, blue is dominant, and we don't have any dominance at all present here. So 0% will be blue. And what percent will be heterozygous? These are all homozygous recessive, so that would be 0%, okay? I'm going to have you flip to the next page, and the next page has two different parents now. Parent one is homozygous recessive again, so two little b's, but parent two is heterozygous dominant, or in other words, there's a big B and a little b, okay? So we're just going to fill in this Punnett square again. So I'm going to go little b, little b, little b, little b, big B, little b, and I always write my big B or my dominant allele. If it's heterozygous, I always put the dominant allele first, okay? And down here we have big B, little b. So I'm just going to write in my 25, 25, 25, 25. Okay. So what are the possible genotypes from this cross? Well, I have little b, little b. Remember, genotype, genes, it's your genetic makeup. And here I have big B, little b, big B, little b. So those are my two genotypes. the two possible phenotypes. So little b, remember that purple is little b and blue is big B. So these guys here will both be recessive, which is purple skin, so purple. And these two will both express the dominant allele, which is blue. So my possible phenotypes are purple and blue. Oh, went out of focus. There we go. What percent would be purple? Okay, so here purple is little b. So these two, if we add 25 plus 25, these two will both be purple. So we had 50% purple, and we had these two would be blue. Blue is dominant, so I had 50% blue. And then what percent would be heterozygous? Big B, little b is heterozygous, and big B, little b is heterozygous. 25 plus 25 gives me 50%. Okay? All right, now we're going to flip to the last Punnett square. Okay, so here we have a different cross. Parent number 1 is homozygous dominant. Homozygous, both the same. Dominant, they're both big B's. Crossed with homozygous recessive. Homozygous, both the same. Recessive, meaning both recessive. So I'm just going to fill in my Punnett square. Now, I just wanted to point out, notice that I put the dominant allele first in all 4 boxes, okay? I always want to write the dominant allele first, and the reason I do that is the dominant allele, especially in a heterozygous organism, the dominant allele is the one that will be expressed. The recessive allele is there. It can be passed down to future generations, but it is not expressed. So in my mind, it's secondary. So I put it second, and I put the dominant allele first because that's the one that we're going to actually physically see in our organism, okay? So I'm just going to fill in, 25, 25, 25, and 25. So let's see if we can figure out what our possible genotypes are here. All right, genotypes. So that's our genetic makeup. Every single box is big B, little b. So that's going to be 100%. What are the possible phenotypes? That's your physical characteristics. So the possible phenotypes are blue is dominant and purple is recessive. So we're going to only have, what did I say, blue? Blue was dominant. What percent would be purple? The only way to get purple is if some of these, offspring had little b, because the only way these recessive alleles get expressed is if you have 2 of them. So here we didn't have any of those. So actually 0% would be purple. What percent would be blue? 100%. We kind of already talked about that. And then what percent would be heterozygous? Hetero means 2 different. So here I have 2 different alleles, big B, little b, big B, little b, okay? So 1, 2, 3, 4 out of 4 gives me 100% heterozygous, okay? So again, heterozygous means 2 different. So this is heterozygous here. Notice that these 2 are the same. So homozygous dominant, they're both the same, they're both dominant. Homozygous recessive, these are both the same, but they're both recessive. All right. All right, guys, that's all for today. I hope that helps. Bye-bye.